Hey Raiders, welcome back. I'm here to kind of walk you through what we've been talking about in class, specifically with regard to types of plate margins. We're studying plate tectonics. So we're talking about how lithosphere, again, remember the distinction between chemical composition of the Earth, in which case we talk about crust and mantle and core, and in mechanical properties of that same material in the earth. And in that case, we use terms like lithosphere and asthenosphere. The lithosphere is that rigid part of the Earth's surface that actually moves around. And in the handout that you received in class, it sort of talked about like the shell of a broken shell of an egg. Think of a hard-boiled egg. The idea, though, is that these lithospheric plates move around. They're able to move around because the asthenosphere beneath is more gooey, right? And it's not rigid like that upper part. And again, remember the way I described the lithosphere as being like the graham crackers that you have in s'mores, and the asthenosphere as being like the gooey marshmallow beneath. And again, remember that the motion of those plates is driven by convection currents. Heat rises, and so heat coming up from deep within the earth comes up and pushes plates. And specifically, one of the types of plate margins is where that material wells up to the surface, produces baby crust, and pushes the plates apart. So let's walk through those. And so we have plate margins. That's what we're talking about, plate margins. So we're talking about pieces of lithosphere and how they move around, how they interact as they move. And so the plate margins, we can have the type or the name of the three types of plate margins. We also talk about their motion. We talk about the effect of that motion. And then we want a geographic example of each of these types of plate margins. So we have the type or the name. So the first one that we'll mention here is what we call the divergent plate margin. Divergent plate margin, of course, is what we have where material is coming up deep from within the earth, and it, again, as I said a moment ago, it pushes upward because of convection. Heat rises. It pushes apart the plates there. So we have a divergent margin. We have two plates pushing apart. This is where oceanic crust is produced, where those plates are pushing apart. Baby crust is being formed right there. And remember that the oceanic crust is not only thinner, but it's younger and it's also denser. Continental crust is thicker, it's older, and it's also thicker, older, and less dense. So we have divergent margin. At a divergent margin, we have two plates pushing apart. The effect is that this is a constructive event. New crust is being constructed, or new crust is being formed there. A great example of this is what's known as the Mid-Atlantic Ridge. As I told you in class, this is a type of plate margin where you can have both earthquakes, and I'm just going to write EQ, and you can also have volcanoes at these types of plate margins. Great example of the Mid-Atlantic Ridge is where it actually goes onto land in Iceland, and so you can actually see this plate margin there. And of course, there's lots of volcanic activity in Iceland, as well as seismic activity along this sort of plate, because you've got magma, molten rock, that's pushing up deep from within the earth, and that's going to lead to not only volcanoes forming, but it's going to lead to things rumbling around, right? Seismic activity, energy that's traveling through the crust. So that would be what we would call earthquakes or tremors. So we have earthquakes and volcanoes that can happen at this sort of margin. The second type that we're going to mention here is a convergent plate margin. Again, divergent, you have two plates pushing apart. I'll add arrows here. A convergent margin, you have two plates pushing together. They're coming together. And when that happens, you'll remember that the diagram that I drew showed oceanic crust, which is denser, dipping down beneath continental crust, which is less dense. So the heavier crust dips down beneath the lighter crust. And as it dips down, that area is known as a subduction zone. And that subduction zone, in that subduction zone, you have friction that leads to melting. And then that molten material rises to the surface and produces mountains, volcanic mountains. Volcanoes are there. And so instead of being a constructive margin, the convergent is a destructive margin. You actually have crust that's being destroyed because it's sort of being swallowed up, right? It's being swallowed up at that subduction zone. The oceanic material goes down beneath the continental, melts, comes up, and produces volcanic mountains. A great example of this would be the west coast of South America. And of course, the mountains that are produced by that event are the Andes Mountains. But of course, at this type of margin, we can have earthquakes, massive earthquakes. And again, we, of course, are producing volcanoes. These are volcanic mountains that are produced at this type of plate margin. The third type of plate margin, a little bit different. And this is a transform plate margin. And here, we don't have plates pushing apart or pushing together, but we have two plates that are dragging past one another. So two plates dragging past one another. And even though handouts and books and whatnot that you'll encounter will talk about two plates sliding past one another, that doesn't really seem like the best sort of language to use, because these are rocks and they're not sliding again like a hot knife through butter. It's not like that, or it's not like olive oil in a Teflon cooking pan. Things aren't sliding like that. It's much more, there's a lot of friction. And because there's friction, of course, transform margins often are characterized by earthquake activity. Think of the San Andreas Fault zone in southwestern United States and Southern California. And so this is not constructive. It's not destructive. We're not producing new crust. We're not destroying crust. This is what's called a conservative margin. And our example of this is simply Southern California. That one's a little bit close to home. Some of you may have experienced earthquakes in Southern California if you've traveled there or lived there. And of course, there are not volcanoes along transform margins, but there are earthquakes. So we'll go ahead and add this here, my little abbreviation of EQ. So this is a basic review of the plate margins. One thing I want to remind you is that another place that plates converge is where we have plates, lithospheric plates, that have the same density. And of course, one of those is continental collision. Continental lithosphere colliding with continental lithosphere. And in that case, I'm just going to draw it down here as a reminder. We can have, again, plates coming together, but one's not dipping beneath the other because they have the same density. So they collide. And as they collide, they're pushed upward And again, this is continental lithosphere colliding with continental lithosphere. As they collide, we have this crumpling up of material. This is high pressure. It can be high temperature as well, depending upon where you are in the rock sequence. But this is called a collisional margin. It's a collisional margin. So it's sort of it's a convergent margin because plates are coming together. Two plates are pushing together, but instead of one dipping, these are actually butting heads, and they crumple upward and produce three types of deformation that we talked about in class. It can produce folds, it can produce fractures, it can produce faults. And again, this is what we have where continental lithosphere collides with continental lithosphere. What's produced here, up here in this situation, what's produced is volcanic mountains. What's produced here are what are called fold mountains. It's a fold mountain belt, not a volcanic mountain belt. So both types of margin where plates push together do produce mountains. But in the case of oceanic continental plates coming together, there we would have subduction zone melting that leads to volcanic mountains. Again, like the Andes, if it's a collisional margin, continental meeting continental, crumpling up, leading to deformation, producing a fold mountain belt, examples being the Alps or the Himalayas or even the Appalachians. That's a simple way of describing a pretty complex process. So those are two of our types of mountains that we reviewed in class even just today. So two of the types of mountains are the volcanic mountain belts produced in this situation. We also have the fold mountain belts that are produced at a collisional margin. I'm going to erase this just a second and talk about the other two types of mountains. So we've talked about volcanic mountains. And again, the situation in which that happens is above a subduction zone at a convergent margin. And an example of that, of course, would be the Andes Mountains. We also mentioned fold mountains. Fold mountains, a fold mountain belt. And this happens where we have a collisional margin. And again, just remember, this is continental. Up here, we're talking about oceanic, continental. And an example, again, of fold mountain belts would be something like the Alps or the Himalayas, or for that matter, right in our backyard, the Appalachians. The other two types of mountain belts that we've talked about in class are the Inselberg. Again, in some parts of the US, these are referred to as monadnocks. Inselberg, again, is from the German words Insel and Berg, which together, Inselberg, means island mountain. And again, these are produced through differential weathering and erosion. And the example that we have of this, the one that we discussed in class, is Thickety Mountain in South Carolina. The final type that we discussed in class, excuse me, I didn't write differential properly here, so let me correct my spelling. Differential weathering and erosion. The last one is what we call a fault block mountain. And as you may recall from the diagram that I drew on the board, I'm not going to redraw that here, but these form in what's called an extensional or pull apart tectonic setting. And again, this is where we have faults, steep faults that form as plates are pulling apart. Those steep faults form, and then some of the rock that's sort of loosened up along those faults rises as a big block. And so you have these parts that stick up that are known as horsts. The parts that drop down, it's kind of the valleys, are known as grabens. And so a fault block mountain range, an example of that would be what's known as the basin and range of the western USA. Another example is Western Turkey, where they have these horst mountains, and the grabens, the valleys. And so these are the four types of mountains: the volcanic mountains, the fold mountains, the Inselbergs, the island mountains, and the fault block mountains. And the situations in which they form and examples of each. Remember, of course, too, the name of the boundary between the crust and the mantle. Remember, if we start at the Earth's surface, we're in the crust, we move downward, eventually into the mantle, and finally down into the core. That's the overall structure of Earth. But there's a name for that boundary between the crust and the mantle that's known as the Mohorovicic discontinuity. You'll need to know that for a future test and be able to spell that. So go back and look at your packet, practice spelling that. So this is just the review that I wanted to provide for you so you can go back and check this out at your leisure. Thanks for your attention.